Hey guys, it's Fubar here. Welcome to the Fromzero YouTube channel. Python is a beautiful and complex language that can be used for many applications, from data warehousing, statistical analysis, to social applications, and even gaming. But the truth is, you don't need to learn all of the language to start building web applications. And this is what this YouTube mini course is about. In the next 90 minutes, I will be giving you an introduction to the Python language, specifically the parts you will need if you want to learn Flask, Django, or any other web framework. But before we start coding, I wanted to give you a special thank you for checking out this video. You can get the full course at a special YouTube promotional price or get the ebook for this course absolutely free. Check the links in the description below. And with that, let's start learning Python. In the next couple of videos, we will learn how to properly install Python 3 on Windows and Mac computers, as well as the option to use a cloud-based Python development environment that will let you learn the course without having a computer. Skip to the video that's appropriate for you. My favorite package manager for the Mac is Homebrew, and that's what we'll use to install Python 3. To install Homebrew, just go to the Homebrew website below. Now copy the code on the Homebrew homepage. Now open a new terminal window. You can open the terminal by going to the Spotlight search and typing terminal. Once the terminal window is open, paste the Homebrew code and press enter. Wait until all the files are installed. To check that everything was properly installed, do a brew doctor. Now we'll install Python 3. To install Python 3, just type the following: brew install Python 3. Wait until the script finishes. To make sure Python 3 was installed properly, type Python 3-V. And that's it. Now we can begin our course. My favorite package manager for Windows is Chocolatey, and that's what we'll use to install Python 3. Head over to the Chocolatey install page and copy the code in there. Now open a PowerShell terminal. You can find it by pressing Windows +R and then typing PowerShell. However, you need to run as administrator, so right-click on the window and on the menu select Run as Administrator. Paste the code in the PowerShell window and press enter. Wait until the program is installed. Close the PowerShell window and open it again as an administrator. Remember, every time you use Chocolatey to install packages, you need to run PowerShell as administrator. Check that Chocolatey was installed properly by typing choco-v. If you see a version number, you're ready to go. Now to install Python 3, just do choco install-y Python 3. Close and reopen PowerShell as administrator to make sure the path settings for the Python package are applied. To make sure Python 3 was installed properly, type Python-V. And that's it. Now we can begin our course. I'm constantly searching for the best Python cloud development environment, and I keep coming back to PythonAnywhere. They are completely free, but they have really good plans, they have amazing customer service, and they have MySQL and Postgres support built in. In this lesson, we will look at how we create our PythonAnywhere account. To start the process, please use the following referral link. To be fully open, with this link, I get a small commission if you sign up for a paid plan, and this helps me continue to bring you more good content. Thanks in advance. When you land on the page, you will see a welcome page. Click on the green button to start the process. Here you will be presented with the different plans. For the purpose of this course, the beginner account is more than enough. If you're thinking of hosting a personal site with your own domain or want better speed and performance, choose any of the paid plans. So go ahead and create the account. You will be asked for a username, email, and password. Make sure to confirm your email with the link they'll send you. And that's it. You will arrive to the dashboard. Don't worry about this yet. We'll start covering how to do all the stuff in the coming sections. Like what you've learned so far? Check out the full course and get a special YouTube promotional price, or get the ebook for the course absolutely free. Check the links in the description of this video. Now let's continue learning Python. Before we begin, I wanted to talk about the two major Python versions, Python 2 and Python 3. As you can tell, Python 3 is the latest version of the language. So why are we still talking about Python 2? The truth is, there was a lot of resistance from developers to upgrade to the latest version, and a lot of open source libraries, which are maintained by regular developers and not by companies, were not being upgraded to the new Python version. So a lot of people just stuck with Python 2, even though Python 3 had been out for years. Luckily, as of 2018, most of the important libraries are well supported in Python 3. There's still a handful of libraries stuck in Python 2, but none of them we'll use in this course. Python 3 is the future, and I want you to learn the future. So we will be using Python 3 throughout the course. And with that, let's get started. To have a first good taste of Python, we don't need to go further than our terminal. Python allows you to interact with it using what's called the REPL. That stands for Read, Eval, Print Loop, and essentially it's an interactive shell that lets you write short commands and get the output immediately. To open the Python REPL in Mac, open your terminal and type Python 3, and in Windows, open the PowerShell and type Python. If you use PythonAnywhere, just head over to your dashboard and on the New Console section, click on Python and then the 3.6 button. You will see a message with the Python version and at the end, 3 carets and a cursor. So let's start to write some commands in here, and for the first iteration, we're going to do some basic calculations. Here we are at the Python interactive shell, and we now want to be able to use Python as a calculator. How do we go about that? So let's just enter a simple mathematical expression. Write 2 plus 3 and press enter. As you can see, Python replied with the answer 5. Try another one. Enter 10 minus 3. As expected, we get 7. What about multiplication? We don't use an x, but rather we need to enter an asterisk. So type 3 asterisk 5. Boom, we get 15. Finally, for division, we use the slash. So if we do 21/7, we get 3. Oh wait, we got 3.0 and not just 3. Why is that? This is what we call a type. So the numbers we entered were of type integer. But since a division is usually something with decimal points, Python returned to us a number of type float. We'll be looking at other types in more detail later on. So what would happen if we tried the following command? 3 plus 5 times 2. Pause the video and guess the answer. If you said 13, you were correct. You might have had a good or bad flashback to your math teacher telling you about order of operations. Python works the same way. It does multiplications and divisions first, and then additions and subtractions. The way to alter this behavior is to use parentheses. So let's say for some reason you wanted to do the sum first. You need to put a parenthesis around the 3 plus 5, and then put the times 2 outside, like this. 3 plus 5 times 2. So 3 plus 5 equals 8, and then 8 times 2 is 16. Okay, now you try it. If we have the following sequence, 8 times 3 minus 2, how would you arrange it so that the answer is 8? Pause the video and give it a try. Ready? Okay, so you should have put a parenthesis around the 2 minus 3, so that was evaluated first, which gives 1, and then the multiplication would happen later. 8 times parenthesis 3 minus 2, 8. So try some other things with the calculator on your own and get the hang of it. There are many other math operations available. For example, to get the power of a number, you would use 2 asterisks. So 2 to the power of 3 is written as follows: 2 star star 3. We can also get the remainder of a division, also called modulo, by using the percentage sign. So for example, the remainder of dividing 16 by 3 is 1, since the result is 5 and we're left with 1. So you would do something like this: 16 modulo 3. Don't worry about learning all the math operators. As you build your projects, you will be finding out what they are, and you will memorize the ones that you use the most. For now, try doing some more math calculations on the shell and get acquainted with it. When you are building your applications, often you will need to remember the result of an operation or just plain values. So consider this example again: 2 plus 3. When you press enter, you get a result, 5. In Python, this is called an expression. An expression is a line of code that returns a value right after you hit the enter key. But what if you wanted to keep this value to be used somewhere else, like for example in a later operation? For that, we have these virtual boxes we call variables. Variables allow you to execute the expression, but instead of giving the value right away, it will store it in a box that has a name. So let's try that. Write the following and press enter. Age equals 3 times 5. Wait, what happened to the result? As you might guess, the value 15 was stored in the age variable. So the line age equals 3 times 5 is not called an expression anymore. It's called a statement. A statement is a line of code that doesn't return a value immediately, but instead it does some type of transformation that you can then use in your application. So how do we get the result out of the expression? We can just go ahead and type the variable name in the shell like this. As you can see, now the word age is associated with the value 15. Every time we type age, we'll get 15 until we modify it. So how do we modify it? We just assign a new value to the variable like this. Age equals 21. Now, if you type age, you'll see that 15 has been replaced with 21. That is why they're called variables. Their values can change over time. Try creating some variables and see what happens. Just pause the video and I'll be back to resume. Okay, now for another cool Python trick. Let's say you have egg cartons that hold 12 eggs. We can represent that with the following expression: egg carton equals 12. So now let's say we have a box that can hold 10 egg cartons and we want to know how many eggs we have in that box. We could do the following: box equals 10 times egg carton. Now, if you print the box variable, you can see how many eggs we have in the box. Really cool, right? Python interpreted the value of egg carton first and then multiplied it by 10. So what happens if we change the value of egg carton to 24? What do you think the value of box will be? Don't look. Pause the video and say out loud what you think will be the value of the box variable. If you say 240, it would have made a lot of sense. However, that's not the right answer. You see, the box variable holds what the value of it was until we change it again. Otherwise, variables would be changing all the time without our consent, and that could lead to a lot of confusion to the users of our application. A handy thing to do with variables is to increase them or decrease them by a certain value. So let's say somebody took an egg from the egg carton variable we defined earlier. Right now, the value is 24. So we would do that by doing egg carton equals egg carton minus 1. So we're telling Python to get the value of the egg carton variable, subtract 1 from it, and then save the result in the same variable. Mind blown, right? Now check the value of egg carton. To increase it by 1, just do egg carton equals egg carton plus 1. You can increase by any number you want, of course. Egg carton equals egg carton plus 12. Since this is a pretty common thing to do, Python offers a shortcut for this. So instead of putting the variable again, we replace the equal sign with plus equal, like so. Egg carton plus equals 1. Likewise, we can subtract by 1 by doing egg carton minus equal 1. You can even do multiplication and division, although those are less common to use. Egg carton times equals 2, egg carton slash equals 2. Try creating a variable that stores the number of inches from a measurement and then another one that converts that to centimeters. How will you do that? In the previous lesson, you saw that we named a variable egg underscore carton. So why didn't we name it egg uppercase carton or egg dash carton? It turns out these things are important, and if we didn't have some sort of contract between programmers on how to name variables and many other conventions, our code will look really different from codebase to codebase. So the users of the Python language all adhere to a format called PEP8. You don't need to memorize the whole document, but I want you to take a look because it should be your go-to guide when you don't know how to format something. The more things you look up, the more you'll know how to write them. Remember how we talked about how some values we were getting back from Python were different types? So for example, when we do 3 plus 2, we get 5. 5 in this case is called an integer. It doesn't have a decimal point. But now if we do 9 divided by 3, we get 3.0. The 3.0 is called a float because it has a decimal point. But now imagine we assign these expressions to variables. So let's do a equals 3 plus 2, b equals 9 divided by 3. Just by looking at a or b, we can't tell what variable type they are. So now let's check what type of variable is the ones we used earlier. So just write type parenthesis a. Python is saying that a is a type of int or integer. For now, don't notice too much the word class in there. Think of a class as being the category type of the variable. Now let's do type parenthesis b. Python now says b is a type of float, i.e. a number that's not whole. There are a number of Python types, but let's check the two other most used ones. The first one is called Boolean, and it essentially holds a true or false value. Just those two. So let's type a Boolean. Result equals true. Notice that it's written true with a capital T and not true, all lower caps. That name is a reserved value for Python. So now if we want to check the type, we do type parenthesis result. So Python correctly states that the variable result is a bool or boolean. To change the value to false, we do the following. Result equals false. Notice the syntax of false. The F is capitalized. I won't tell you how many times at the beginning you'll mistype that as false or lower caps. But eventually we all learn. The last type we'll introduce is called string, and we are going to dive deep into it in the next lesson. But as an introduction, strings are a series of characters which can be any combination of letters, numbers, or symbols. So let's try one. Type name equals quote John end quote. That's it. Now the variable name holds the value John. If you type name, you get the string John. And to check the type in Python, we would write type parenthesis name. Python says it's a type of str or string. There's a lot of things we can do with strings, so we'll check that out next. In the previous lesson, we were introduced to the string type in Python. Strings is one of the things you'll use a lot in your application development, so it's good to have a good understanding of the things you can do with them. The first thing to learn, and it's a source of a lot of discussion in any Python development team, is the question of single quotes versus double quotes. So for example, you can do this. Name equals quote John end quote. Or this. Name equals double quote John double quote. The Python interpreter will be fine with both. So the principle I use is the following. Use single quotes unless you have a single quote in the string. For example, let's say the string is John's horse. You would use sentence equals double quote John's horse end double quote. If you used single quote John's horse single quote, that returns an error. Sentence equals single quote John's horse single quote. The second thing to learn, and this one is super important, is that strings are also lists. What is a list? It's a sequence of values that have an order and an index. We'll see lists in the next lesson, but for now, visualize this. This is a string with the word hello in it, but we can also get to specific characters of that string using an index. So try this in the terminal. Greeting equals hello. So if we want to just extract the E in hello, we can do greeting bracket 1. Notice that format? We use the variable name, then in brackets, the character index we wanted. We can get slices of the string by adding a colon and another index position. So for example, to get ELL from the variable, we do greeting bracket 1:4. Notice that we specified 4 in the second number, which corresponds to the O character. However, the slice doesn't include the last character, so the above expression reads, get me the characters from index 1 and below index 4. Did you see that we also have negative numbers in that chart? That's because the list also has a negative index, which is handy, for example, if you want to get the last character of the string. And you can also do a slice as well. Greeting bracket -4 colon -1. The above reads, get me the character from -4 to, but not including, -1. Notice the slice always goes left to right. Doing it backwards doesn't work. Greeting -1 colon -4. The last nifty trick with slices is that you can leave the second number out, and that signifies until the end of the string. So for example, if we want to get the slice from E until the end of the string, we do greeting bracket 1 colon. And that also works with negative strings. Greeting bracket -4 colon. Okay, now you try it. How would you get the string LLO both from the positive and the negative index? You can join two strings by using the plus operator. So let's say you have a greeting and a name variable. Greeting equals quote hello, name equals quote John. You can join the two by using greeting plus name. Okay, that was too literal. Let's insert something in between. Greeting plus quote, comma, quote plus name. That was more polite. Now let's say we want to have a string that reads how many eggs are left in a carton. So we have the eggs_left variable like so. Eggs left equals 4. And now we write the string, quote, there are, end quote, plus eggs_left plus, quote, eggs left in the carton. Whoa, what happened? Python is telling us that we can't mix a string and an int or integer number. We must convert the number to a string. To do that, we use the built-in function called str. Quote, there are, end quote, plus str x_left plus, quote, x left in the carton. What if we have a string that does have a value and we want to add it to a number? For example, if we define x to be a string with the number 5 in it and y an integer with the number 5 in it, x equals, quote, 5, end quote, y equals 5. And we want to add the two as numbers. We can convert the x to a number using another built-in function called int. Int parenthesis x plus y. We can also convert it to a float by doing float parenthesis x plus y. Now let's say we have two variables we need to output. Now we have a carton serial number, carton_number equals 25. And we want to know the number of eggs left in that carton. We could do there are str eggs left plus eggs left in carton number plus str carton number. I mean, it works, but it's starting to get messy. And one of the principles that Python developers share is to write clean, readable code. When you write good Python code, it's referred to as being Pythonic. Python allows us to do string interpolation, which is a fancy word to say replacement of values in a string. For that, Python 3.6 introduced the f function for strings. So we can directly insert the variables in the string by doing this. F, quote, there are bracket x left in carton number, bracket carton number. Isn't that much more readable? I think so too. You can assign the f string to a variable as well. Output equals f, quote, there are bracket x left in carton number, bracket carton number. There are a number of methods or functions that are integrated into strings, and you execute them by using a dot notation. For example, let's say we want to put all characters in all caps for a string. Using the name variable before, we can do name equals, quote, John, name.upper. Notice we need to use an open and close parenthesis at the end of the method. That's to signify we are not passing any parameters to the function or modifiers. We want the function to execute immediately. We'll look at functions and parameters later in this section. We can convert all the characters to low caps by doing name.lower. We can strip the space characters from the beginning and end of a string like this. Spaces equal, quote, space. This is a bunch of spaces. Space, quote. Spaces dot strip. We can separate a string into a list of strings using a specific character. Joined equals, quote, A/B/C. Joined dot split, parenthesis, slash. And we can even join a list of strings with a separator between them by doing separator equals slash separator.join ABC. There are other methods available, but don't worry, you'll learn them as we go along. The last built-in function for strings that I want to show you, and that's really useful for strings, is len, which tells us the length size of a string. Greeting equals, quote, hello John. Len of greeting. The len function also works for lists, but you shouldn't be surprised about that. Now you try it. Say you have a list of product numbers in a string like this. Stock equals, quote, 122, 455, 677. Create an F string that outputs there are 3 products in stock. Try it now and come back for the solution. So I would do it like this. Products equals stock dot split, comma. And here was the tricky part. Remember I told you len also works for lists? So you can do number of products equals len of products. And now do F, quote, there are, bracket, number of products, products in stock. Hope you had fun with that one. In this lesson, we'll check out 3 very important types in Python. Let's start with lists. We've seen a bit of list type in the previous lessons. It's essentially a collection of ordered items. So a list could be IDs equals 1, 2, 3, 4, 5. As we saw in the string lesson, we can get an element of the list by passing its 0-based index number. So to get 2, we do IDs of 1. We can also get a slice with the index number and the upper bound, but not included index number. So to get 2, 3, 4, we do IDs 1, 4. Now, here's something interesting about lists. Remember when we had the following? X equals 3, Y equals X equals 6, and then Y. Thus, the value of Y was not updated when X changed. The name for this behavior is called mutability. Numbers and strings are called immutable in Python, i.e., they don't change. But when you assigned X to the new value of 6, internally Python didn't change the variable. It created a new version of it and left the previous version in a limbo state where it might be deleted at any point it's needed. But lists are mutable, i.e., they can change. To check this out, let's check that list we had before, IDs. Now let's assign a new variable called nums to IDs. Nums equals IDs. And now change one value in IDs. IDs of 2 equals 6. Now look at nums. The third element of nums also changed. Keep this in mind when dealing with lists. We already know that to get the size of a list, you use the built-in function len. Len of IDs. We can check if there's a value in a list by using the built-in function in. This function returns a boolean. Let's try it. 2 in IDs. 10 in IDs. To add a new element at the end of a list, you'll do IDs.append 6. Notice we have 6 twice, and the list is fine with that. If we wanted to replace that first 6, we just replace the value on the index position like we saw before. IDs of 2 equals 3. To get the position of a value within a list, we can do the following. IDs.index of 4. And can remove a value by doing IDs.remove 6. You can also remove an item with the del built-in function. For example, to remove the value in the 4th zero-based index, we do del IDs of 4. By the way, we can use del to remove a variable as if it never existed. Tuples are like lists, but with one key difference. They are immutable, like strings and numbers. They are defined using parentheses instead of brackets. Chords equals 25, 64, 98. You can get the first value of the chords tuple with the 0 index notation, chords of 0. But if you try to replace the value of the first value, you get an error. Chords of 0 equals 18. You can also get an error if you try to append a value. Chords.append 128. So when would you use a tuple instead of a list? The main reason would be if you want to set a list of things that you want to make sure won't change later in the code. You are sort of protecting that the tuple is kept as you defined it initially. Things like code settings or options in a select field are good candidates to use tuples. But don't worry if you don't get it now fully. Once you use them, you'll see the difference more clearly. Really useful data types are dictionaries. Dictionaries are also sequences, but they have a key and a value. Let's see what that looks like. Countries equals US, United States, CA, Canada, MX, Mexico. Now, instead of using the 0 index method to get a value, we use the key. For example, to get the value Canada, we do countries of CA. We can add key value pairs to the dictionary by creating a new element like this. Countries VE equals Venezuela, countries. Just like lists, we can get the size of the dictionary, len of countries. And we can delete an item using del, del countries CA. We can also update an item easily. Countries of MX equals Mexico. And if you were wondering about it, yes, dictionaries are mutable, so assigning another variable to the countries list will change it if something changes in the dictionary. You can also check for the existence of a key in a dictionary. VE in countries. But that doesn't work for values. Venezuela in countries. However, dictionaries have two methods that return a list of their keys and values. Countries.keys, countries.values. And interesting enough, it has a method that returns a list with tuples of the key value pairs. countries.items. This is really useful when we want to scan the dictionary for some reason. We'll see more of these types of operations later on. A frequent issue you will have is to know if a dictionary has a specific key. Sometimes the dictionary is being returned by another function or library, or you're dealing with user input and you don't know for sure the contents of the dictionary. If you try to access an inexistent key, you will get an error and the program will crash. Let's see that in action. Countries of IT. There's no Italy in our countries, capiche? So in order to safeguard the program and test gracefully if it has that key, we use the built-in get method that the dictionary provides. So to test this without risking to crash the program, we do countries.getIT. Nothing happened, and that's good. Now, if I try to get a country that does exist, we get the value. countries.getUS. We can also assign a default value to the get so that we can load a value we want in the case the key doesn't exist, like this. countries.getIT, no country found. Now it's your turn. Try your hand with lists, tuples, and dictionaries. Try to get specific elements, slices, and adding and removing items. And here's a question for you. In the countries dictionary above, with what you've learned so far, how would you find out if a specific country is on the values of the dictionary? Think about it and write it down. I'll tell you the solution in a second. Ready? So to get if, say, Venezuela is on the values of the dictionary, I would do the following. Venezuela in countries.values. Did you get the same result? Cool. Let's move on to the next lesson. Looping refers to executing an operation or group of operations repeatedly until a condition is met. There are many reasons why we would want to do a loop, and they're usually related to lists and dictionaries, so now's a good time to review them. The first looping command is the built-in function called for. So let's say you have the following list. Numbers equals 1, 2, 3, 4, 5. We want to write a script to write all the values. So that would look like this. For number in numbers colon. That statement above loops for every item in the numbers lists, assigns it to a variable called number, and executes the block below. Since the list has 5 items, whatever is below will be executed 5 times and then it exits the loop. Now press enter and notice that instead of the 3 arrows, we have 3 dots. Python is expecting us to continue writing the code. And that's because when we use the colon at the end of a statement, Python is expecting a block. A block is a series of statements that are associated with the line above. So how does Python know which commands belong to the statement and where does it end? It's really simple, by the spacing. So any commands we want to execute n number of times under that for statement need to have at least 1 space before it. The Python formatting guide PEP8 recommends 4 spaces, so that's what we'll use. I know it might sound confusing right now, but don't worry, it'll make sense soon. So let's continue the statement. Enter 4 spaces and then write print number. Printing variables just using the variable name is a quick way to see the contents in the interactive terminal. But here we've started using the print command, as that's what we would be using in a real Python script. We could have written just the variable name here, and it works too, but it wouldn't work in a real script. Just remember to put print and whatever you want to print surrounded by parentheses. Notice that when you press enter after the print statement, you get another 3 dots. Python is giving you the chance to continue writing more statements on that block. To exit the block, just press Enter. Now Python knows we're done with the loop and executes it. Now let's try the loop with two commands. Do the following. For number in numbers, print dash print number. As you can see, all the statements with the spacing in front get executed once in every loop. You can also loop through dictionaries using the for function, but the values are a bit different. So let's create a dictionary with three values. Numbers equals A1, B2, C3. Now we loop using the for function. For number in numbers, print number. Okay, so we're getting the keys, but not the values. For that, we would use the values method. For value in numbers dot values, print value. We can also get both the key and the value at once using the items method. Since each loop will return a key value tuple, we can assign it to variables dynamically by doing for key value in numbers dot items, print key value. Notice how we can use a comma in the print statement to print two values that are of different types. Can you figure out what would happen if we had just done print key plus value? There's another loop function called while. While executes the loop as long as a condition is met. We will see conditionals in detail in the next lesson, but for now I'll give you a quick advance. We can check if a value is less than another by using the left angle bracket. So for example, if we want to find out if 3 is less than 5, we do 3 lower than 5. So let's say we want to do the same printout of 5 numbers, but without creating a list. We could do the following. I equals 0, while I is less than 5, I equals I plus 1, print I. As you can see, the loop executed the statements until the value of I reached 5, or in other words, while the value of I was less than 5. The moment the value of I was higher than 5, the loop stops executing. There's a built-in function that's useful to generate these sequential lists, and it's called range. So for example, to generate a list of all the numbers from 0 to 99, you would do numbers equals range from 0 to 100. Let's check the last number of that range. Numbers of -1. So now you try doing the following challenge. Generate a list using range called IDs that has the numbers from 0 to 20. Now do a for loop that prints all the numbers. Next, do the same but only using a while loop and no range. Like what you've learned so far? Check out the full course and get a special YouTube promotional price, or get the ebook for the course absolutely free. Check the links in the description of this video. Now let's continue learning Python. Sometimes we need to make decisions and add a fork in the road in our scripts, and that's what we get with conditionals and control flow. There are a number of conditional operators that allow us to check for the relationship between two items. Let's go quickly over them. We already saw that if you used an equal operator on a variable, the expression on the right is assigned to the variable on the left. But we can check if two values are the same using the double equal operator. So for example, let's say we have two variables and we want to test if they're equal. We can do x equals 5, y equals 6, x equals y. As we can see, the result is a Boolean value, and it's false, of course, since 5 is not equal to 6. The opposite of that is the not equal operator. So we can do x is not equal to y. We already saw the greater than operator in our while loop, But just to refresh our memory, we can do x is greater than y. The opposite of that would be the less than operator. X is lower than y. We can also test if a value is greater or equal to another. We can do it like this. X is greater than or equal to y. And the opposite would be less or equal than. X is lower or equal than y. Now take note of the format. You can't do x equals less than y. Always remember to put the angle bracket before the equal sign. Conditionals are not limited to numbers. We can also do comparisons between strings, for example. X equals John, Y equals Jane, X equals Y, X is not equal to Y. For two strings to be equal, they need to be exactly the same. So if we have X equals John, Y equals lowercase John, X equal Y, false. One handy trick you use often is to use the lower method for strings to check if they're the same. So in the example above, we could do x.lower equals y.lower. This is true because we converted both strings to lower caps. So you can also do greater than or lower than with strings. In that case, the comparison will be based on the alphabetical order of the strings. So for example, alpha equals A, omega equals Z, alpha is lower than omega. This will come handy when we want to sort strings in alphabetical order. We can also group conditionals just as we did arithmetic operations using the and or logical operators. We use and when we want all conditions to be true to return true, and or when we want just one of the conditions to be true to return true. Again, using the variables x equals 5, y equals 6, we could test the following with and. X equals 5 and y equals 6. So because we're testing that both values are equal to their actual values, we get a true. However, let's do one condition to be true and the other false and see what happens. X equals 5 and y equals 5. We get a false, which makes sense. Both expressions are not true since y is not equal to 5, so the whole expression fails. Now if we used an or, that would look like this. X equals 5 or y equals 5. Here we get true because we just needed one of them to be true. There's another logical operator called not, which negates or switches the expression after it. So for example, we can do x equals 5 or not y equals 5. We could read this as if x is equal to 5 or y is not equal to 5. Of course, the second part of the expression is true since y is not equal to 5, so we get true. Python has a built-in constant called none, which is a special value. It detects if a variable has value or not, but it's not exactly 0, as 0 is a value. It's more equatable with void. You can also assign it to a variable to denote that it doesn't have a value yet. For example, let's say we set a new variable z to none. Z equals none. At this point, we're saying z is not set yet. It can be a number or a string, we just don't know yet. We could test if a variable is none by doing z equals none. However, PEP 8 says the following. Comparisons to singletons like none should always be done with is or is not, never the equality operators. So always use the identity operators is and is not to check if a variable is none. Z is none. They are called identity operators because they are really checking if the two values belong to the same location in memory, not if the values are the same. That's also why it's much faster to test z is none than z equals none. Geek alert! Here's a function to check the memory location of a variable. ID of z. Now compare that to the ID of none. ID of none. See how the numbers match? That's why z is none. Now if we set z to 0, it's no longer none. Z equals 0. Z is none. Just like mathematical operators, we can also group logical expressions with parentheses. So to continue with our variables, x equals 5, y equals 6, z equals 0, we can do the following expression. X equals 5 and parentheses, y equals 6, or z is none. So Python here does the calculation of the logical operators in the parentheses first. Y equals 6 or z is none. And then does the AND operation with the first part of the statement. X equals 5 and true. Armed with the logical operators, we can now control the flow of our script based on the outcome of these comparisons. Just like with the loops, by indenting or putting spaces in front of a group of lines, we can enter or skip these groups or blocks depending on the truthiness of the statement. Let's do an example. Name equals John. If name equals John, print it's John. As you can see, the block indented under the if statement got executed. If we had more than one line and it had the same indentation, it would have been executed as well. We can combine the if with another conditional statement called else. The block under the else will be executed if the logical statement after the if is false. So we can do the following. If name equals James, print it's James. Else, print here's Johnny. Finally, we have a third conditional that can further test another comparison if the first if is false. It's called elif, and it means else if. In the previous example, it's dangerous to assume that if the name is not James, then it has to be John. So we'll use an elif instead. Name equals Juan. If name equals James, print it's James. Elif name equals John, print here's Johnny. Else, print I don't know him. Remember to put else at the end of the comparisons. Otherwise, it will be executed before you test for any other conditions. Sometimes we want to stop the iteration of a loop or to skip to the next iteration, and there are two commands to do so. Let's see each one in action. So let's build a numbers list with the numbers from 1 to 10. Numbers equals range of 1 to 11. For numbering numbers, print number. If number equals 5, break. So break just exits us from that loop. But let's do another use case. With the same numbers list, let's say we want to print only the even numbers. Remember the modulo function that gives us the reminder of a division? If we divide a number by 2 and get a modulo of 0, that means it's an even number. So with that, let's do, for number in numbers, if number modulo 2 equals 0, continue. Else, print number. Notice how with this continue, the loop just skipped the rest of the code and went back to the beginning with the next item. Let's say we have the following sequential list of numbers. I want you to create the reversed version of that list in another list called reversed numbers. How would you do that using loops and lists? Pause here and continue when you have the solution. Okay, ready to see how I did it? I created the empty reverse number list first, as you always want to initialize variables that you'll be adding things to. Then I made sure to initialize the numbers list. Numbers equals 1, 2, 3, 4, 5. My idea is to do a loop that starts from the back of the list and moves toward the front of the list. So for example, on the first iteration of the loop, I would get the last number of the list and append it to the list, and the second time around, get the second to last, and so on. Remember how there were negative indexes on lists? So for example, the -1 index of numbers is the last number. Numbers of -1, 5. The second to last number would be -2. Numbers -2 is 4. Do you start to see a pattern there? If we subtract a number to that index, we get the previous number and so on. So let's define that variable as reverse index. Reverse index equals -1. And once we get the index, we can append it to the reverse numbers list. Let's call it loop number, and then append it to reverse numbers. Loop number equals numbers reverse underscore index. Loop number. Reverse numbers append loop number. Reverse numbers. Then we can subtract 1 to the reverse index, get the loop number, and append that to reverse numbers. Reverse index minus equals 1. Loop number equals numbers reverse underscore index. Reverse numbers dot append loop number. 5, 4. So here's the whole code. Did you do it in a different way? It's very possible. If you got the same result, that's a good sign. Even though technically not a Python type, data objects are an important part of any application. Python offers a set of helpers that are part of the language called standard libraries. You will be discovering many of them throughout the course, but we're going to check out the datetime library. Python allows you to import these libraries by using the import function. So let's try importing the datetime library by doing from datetime import datetime. You don't see anything happening, but internally, Python just loaded the datetime library into memory, sort of how Neo loads his knowledge of Kung Fu in a few seconds in the Matrix. The import command looks a little weird, with the datetime repeated twice. You're really importing the datetime library from the datetime module, which also has other libraries like time and tzinfo. Now let's try getting today's date. Datetime.today. The date and time you get is the system's local time. In my case, it's Eastern Standard Time in the United States. As you can see, we get an object that has a bunch of values. You can probably figure it out, but they are the different components of today's date. So the first number is 2018, which is the current year. The second value is the month. The third is today's date. And then we have the hour, minute, seconds, and milliseconds. You can extract the different components by using some custom methods. Let's assign today's date to a variable. Today equals datetime.today. Now we can get the year, month, or day. Today.year, today.month, today.day. We can also get the difference between two dates by doing a simple subtraction. So let's say my birthday is May 25th. I can tell how many days until my birthday from today by subtracting the oldest date from the most recent. So let's set a birthday variable. Birthday equals datetime 2018 5/25. Now we can subtract the birthday from today. 2_birthday equals birthday minus today. The to_birthday object is not a datetime object, but a different type of object called time delta. Check it by doing a type command on it. Type 2_birthday. We can get the number of days to my birthday by doing toBirthday.days. You can also get how many days you've been on this planet by setting the date you were born. Was_born equals datetime 1969 5/25. Age equals today minus was born. Age.days. That's a lot of days. But let's get the age in years. We can do age.days divided by 365. That would be a cool answer to how old are you? We can calculate any dates in the future or past from another date by using the time delta object. First, import the time delta library. From datetime, import time delta. So for example, if we want to know the date 1 week from now, we can do today plus time delta, days equals 7. Or to get the date a month ago, today minus time delta, days equals 30. The last thing we'll check out is the UTC time method. As you might know, there's dozens of time zones around the world and even here in the United States. Keeping track of all the time zones in your application quickly becomes something of a headache. That's why in your application, whenever you want to store the date and time of any event, like a user registration date or the date of the latest post, store it using UTC. That way, you have a unified time for all users and you can translate it later to their local time zones. That's the way professional developers do it. To get the UTC time right now, just use datetime.utcnow. And that's all the datetime we have. See what I did there? We've come a long way in this Pythonic introductory trip. The time has come to exit the Python interactive shell and write ourselves our first file. For that, we will start using the terminal. A sign that you are on your way to becoming a professional developer is the lack of fear of opening the terminal and have a permanent shortcut for it pinned in your launcher. For Windows, we will use PowerShell, and for Mac, we will use Terminal. On PythonAnywhere, we'll use the Bash console on the dashboard. To open PowerShell on Windows, just go ahead and type PowerShell on the Cortana search. On Mac, hit the Spotlight search icon and type Terminal. On PythonAnywhere, hit the Bash button. You will be placed in your home directory. We will create a folder for our Python scripts. So go ahead and type make dir python_tests on the terminal and press enter. You just created your first folder from your terminal. Big stuff coming. Now we need to change to that directory. Type cd python_tests and press enter. You are now in the python_tests folder. You can double check by looking at the command prompt, those characters at the beginning of each line, and check that it says Python tests. Now we need to write our first Python script file. For that, we will need a code editor that allows you to write and format Python scripts. If you're using PythonAnywhere, you can skip this section as we will be using their online code editor. For the purpose of this course, I will just use GitHub's Atom editor. So go to the Atom editor's homepage, atom.io, and download the file for your operating system. On Mac computers, the Atom editor will be downloaded on your Downloads folder. Make sure to move it to your Applications folder before running it. Open the Atom application. You may get a couple of welcome tabs. If you want to hide this every time you open Atom, just click on the check mark titled Show Welcome Guide. Now quit Atom with File Exit on Windows and Atom Quit on Mac. Now go back to your terminal and type atom functions.py. This will open a new file called functions.py on the Python tests directory in our Atom editor. Notice how the file name ends with .py. That means it's a Python file and allows Atom to know how to properly do code hints and coloring. If you're using Mac or Windows, you can skip this section. To access the code editor in PythonAnywhere, head over to the Files section. You can go to the Files page anytime by using the hamburger icon on the top right and selecting Files. Now on the directories, select Python_tests. You're now inside the directory. Now on the Files section, enter functions.py and hit New File. You will now be inside the functions.py file and can start coding. So we're going to write our first function. A function is a collection of statements that are executed every time you call the function. So write the following code on the editor. Def my_function, print hello world. Notice how after pressing enter at the end of the first line, the editor automatically puts spaces for us to indent the print statement. From this point, I will be putting a link to the lessons code I write on this slider. Just go to your browser and type this URL. Now save the file. Using the key shortcut Ctrl+S on Windows or Command+S on Mac. You'll notice the little blue circle next to the name goes away. On PythonAnywhere, hit the Save green button on the navbar or use Ctrl+S. So how do you run this code? Since we will be switching between the terminal and the code editor all the time, I suggest you put both windows one on top of the other on Windows and Mac. On PythonAnywhere, open a new browser window and open PythonAnywhere again. You don't need to hit the Bash blue button again if you have an existing open console, as this would create a new Bash terminal. If you don't have any consoles open, then hit the Bash button. Now rearrange the two browser windows, one on top of the other. Make sure you're on the Python tests folder. If you don't see Python tests on the command prompt, change to that directory. Now on the terminal, type Python functions.py on Windows, Python3 functions.py on Mac and PythonAnywhere, and press enter. What happened? Nothing was printed on the terminal. What happened was that Python registered the function, but we didn't actually tell it to run the function. The way we do that is by calling the function. So write this at the end of the file. Save the file and run the script again. Bingo! Now we get hello world. Now check out what happens if we add another line below the print statement. Let's say we add another print statement below the first one. Notice we're keeping the same indentation like the first line. As long as the two lines have the same number of spaces, they are grouped under the function. Save and run again. You'll see the 3 dashes below. Functions can accept incoming data through the use of their arguments. Arguments can be thought as variables that are being set from the outside and passed to the function. Let's try that. Add a name argument to my function inside the parentheses, and the same variable to the first print statement. Finally, let's add the name John to the function call. Now save it and execute it. We get hello John. Now add a second call to the function with another name. Save and run. You can see the power of this, right? You can call this function with a new name and the output is different. We can have more than one argument on the function. Let's try that quickly. Change the name argument to first name and add a second argument called last name separated by a comma. Next, change the print statement to have the first name and last name arguments using the f method. Finally, change the function call to have the first name and last name. Now if we run the script, we get hello John Jones. Most functions don't print things inside of them. Of course, some of them will, but functions are usually little black boxes that return the result of their computations. Let's adapt our function to return the full name we passed to it. So instead of printing, let's assign a variable called full name to the combined first name and last name string and then return it to the caller. Then on the function call, let's assign the result to a variable called composed name and print it. If you run it, you'll get the exact same result. The last thing we'll learn about functions are the two different argument types. So the first name and last name arguments are also called positional parameters. They are positional because the function is expecting the first parameter you pass to be the first name and the second has to be the last name. You can't call the myFunction function with last name and first name as the parameters. If you pass Jones, John in myFunction, it will return the results backward. They are also required arguments. If you try to call the main function with only the first name, look at what happens. Now run the script. Python is telling us the function is expecting two arguments, not one. So let's say we know for sure we'll have the first name and last name data, but the inputs could have an optional address and or a phone number. We could do the following. Add the address and phone number arguments, but assign both to none. Notice the PEP8 format here. You put the equal sign without spaces. By pre-assigning the value none to these arguments, you are declaring them to be keyword arguments which have the following characteristics. They are optional. You can pass them on the function call or not. They are not positional. You can pass them in the order they are set in the function, or you can call them in a different order if you pass their keyword names. Let's put some conditionals on the function to check if the address and phone are passed, and add them to the customer record. Finally, we'll change the combining return variable to customer data. Let's put 4 different calls to the function to see what happens. Notice how on the first call with John Jones, we didn't pass the phone or address. On the second call with Jane Jones, we don't pass the phone number. On the third call with Julia Jones, we're passing both address and phone, but using them positionally. On the fourth call with Robert Jones, notice how the phone and the addresses are in reverse order, but because we're passing the keywords before them, the function is able to figure things out. There's an important functionality that you should know about variables that we haven't talked about, and that's the concept of scoping. So far, when you have created variables, you just assume they're available everywhere. Turns out that variables inside of a function or classes, which we'll see later on, are scoped to that function or class and are not available outside of that code block. Let's try this by adding a new print statement at the end of our function py. Now run the file and see what happens. Even though we're setting customer data in the myFunction function we executed, customer data is nowhere to be found. This makes a lot of sense because of a principle you should always be mindful of, and that's the principle of encapsulation. Your code should always have little black boxes that do things when called, but that don't modify any external variables, but rather return values that are assigned outside. That means code that's more maintainable and better organized. Python introduced recently a way to override that, using the global and non-local keywords. So for example, if you wanted customer data to be available anywhere from the outside of a function, you can add on the first line of the function the following statement: global customer data. Now run the code and you will see it works. If you define a variable at the topmost level of the code, that variable is available inside the inner functions. For example, if we define another variable outside called noAddress without adding the global keyword, we can access it from inside of the function. So on line 1, do noAddress equals false. And in line 21, insert print noAddress, noAddress. Now run the script and you'll see noAddress printed out. Let's change noAddress inside of the function to see what happens outside. Add the following in line 7. Now cut line 24 and paste it in line 16 and 19. If we run the file now, we see that on the outside, noAddress was not changed. That's because even though noAddress is available to be read within the function, when you change it, it's actually creating a new noAddress local variable. So we declare noAddress to be the global variable outside the function to let Python know we want write access to the variable inside the function. Put this in line 5. Global noAddress. Save and run the script. You'll see noAddress changes accordingly. I won't cover non-local here, but it's essentially similar to global, but it just exposes the variable to the outer function, but not globally. However, and this is what I highly recommend, don't use global or non-local, period. It's just bad practice to be allowing external variables inside of functions and variables set in functions to be available outside. There might be 1 or 2 edge cases where I could see this being valuable, but I'm talking 0.5%. Just please don't use this and use parameters and returns instead. That is all we have for functions. Now it's your turn. Try to create a function that accepts 2 numbers as positional arguments and returns the sum of the two, and an optional third number argument that, if passed, makes the function return the average of the 3 numbers. Once you've tried it, let's check the solution. Here we have the function with the 3 arguments, number 1, number 2, and number 3, with number 3 being optional. Then we check if number 3 is being passed. Calculate the average by summing the 3 numbers and divide it by 3, and then return the value. Otherwise, just sum up the 2 first numbers. Hope you had fun with that one. Congratulations on finishing this introductory video. You now have a good initial understanding of how Python works. Please let me know if you have any questions or are stuck with your code using the comment section. And don't forget to subscribe if you liked this video. I'm constantly putting new stuff to help you become a professional developer. See you soon!